Easy problem today. We want, given some numbers, want to find GCD of min and max. This already doesn't matter. What does matter is that we find minimum and maximum in a single iteration. After that, we use GCD. GCD is greatest common divisor. So, for example, number 6 and 4 have a common divisor of 2. And you can remember how to write it recursively, like with mnemonic A, B, B, A, B. This is how I remembered it. Basically, when you're dividing A by B, you have to make sure B not equal 0. And if it's 0, just return A, and else return recursively GCD of B, A, B, and insert this percent sign just to make it a reminder. So this is a function GCD. Okay, what else is interesting about this function? The interesting fact is that how geometry can. So GCD is a geometry problem. When you have some rectangle with sides of, for example, side of 8 and side of 5, this is a rectangle, and GCD asks the question, what is the greatest square that can split this rectangle? So we're doing cutting the squares like -5. This is the first step of the GCD recursive function. Then we do like this is 3 and this 3 by 3 cut, and this is 2 again 2 by 2 cut, and finally we have 1, and 1 is the GCD. And by the way, this is the smallest 5, and 8 is the smallest number of 3-step GCD. Why? It is because this is a Fibonacci function. Fibonacci, like we have the sequence of 1, this is 1, just again 1, and then 2, and then 3, and then 5, and so on. This is a Fibonacci sequence, and we have this 8, like 5 plus 8, 12, 8 plus 12, 20, and so on. This is a Fibonacci sequence, and it gives you the longest GCD steps required to find this GCD. And the GCD of Fibonacci is always 1 because it goes to the root, by the way. So the time complexity of this entire function is n, because we have n numbers, but the time complexity of the GCD, is logarithm of Fibonacci of 1.6. In a worst case scenario, we're going exactly logarithm of this Fibonacci golden ratio logarithm step. So this is how it works. I can show you in another example, like 6 and 10. 6 and 10. Let's define. So we have 10. Oh, this is 10. 3 plus 3 plus 2 plus 2. This is 10. Okay, and then we go with 6 plus 3. So Fibonacci GCD of 10 and 6. We go and we find this is cut the rectangle or square. So this is 6 and this is 6. Oh, I'm sorry, cat, kitty cat, sorry. This is 6 by 6 and this is 4. And we cut in this 4 by 4 rectangle. And this is 2. And then we cut in 2 by 2. And finally we have the GCD is the 2. So equal 2. This is how it looks like. And this was a 2-step GCD. Okay, I think I explained it all. Let's look at the code. This is what was accepted. We can do shorter version. And let's look at the shortest Kotlin. This is one. I decided to make it recursion. The tail rec keyword doesn't give me any speed, but we have only 1000 elements total. And this is a Rust. This is what I found the shortest version. It is use sorting just to make code a little bit shorter, but we can use itertools. It gives us minmax value, and we have to convert it into option, and we can do it match with 2 arguments, and it perfectly does the thing, and we don't have to have separate function for the GCD, because we can inline it. Okay, that's it for today.